you've been following the markets or even just, the tech world in general, Bitcoin is having this massive resurgence. But this isn't just about price. It's about a quiet revolution happening right at the base layer, one that really kicked off in early 2023.
Oh yeah, you can pretty much pinpoint it to January 20th, 2023. That's when the Ordinal protocol launched.
Yeah.
And that just opened the floodgates for embedding data, what we now call inscriptions, right onto Bitcoin.
And that spark really lit the fuse for the bull market that followed the 2021 peak.
It really did. I mean, since that date, we've seen something like, over 55 million inscriptions created? It's been incredible.
Okay, so let's unpack this. Our mission today is to go way beyond just, digital JPEGs. We're diving deep into a really powerful idea called digital matter theory, or DMT. And we're going to use the Natcats collection as our main case study. It's maybe the ultimate example of Bitcoin native generative art.
And to really get why Natcats and DMT are so brilliant, you first have to understand the plumbing, the infrastructure that even made it possible. We have to quickly touch on two huge Bitcoin upgrades: segregated witness SegWit and Taproot.
Right. Let's start there. Bitcoin was always meant to be, peer-to-peer cash. So how did something like SegWit or BIP 141 create the space needed for all this art and code?
Well, SegWit was a game changer. It basically solved two big problems at once: transaction malleability and scaling. Before SegWit, the digital signature, which is pretty bulky, was mixed in with the main transaction data.
Right, and that could cause problems with the transaction ID of the TextID.
Exactly. Someone could slightly alter the signature, which would change the TextID, and it just created chaos. So SegWit's genius was separating that signature data, calling it witness data, and moving it outside of the main transaction block.
Okay, so it secured the transaction, but where does the extra space come from?
It introduced this new concept of block weight. So the old block size limit was still 1 MB, but the new maximum block weight, which includes that separate witness data, could be up to 4 MB. And because the witness data gets a kind of discount on its weight, it effectively opened up this huge, secure storage compartment in every block, perfect for data-heavy stuff like inscriptions.
So SegWit gave us the space, got it, but then came Taproot with Schnorr signatures. I remember that was all about privacy and efficiency. Was that really necessary if we already had the room?
Oh, absolutely necessary. I mean, Schnorr signatures are just way more compact than the old standard. They make transactions smaller, which is crucial when you're trying to embed, a whole piece of generative art code.
And Taproot used those signatures with, what was it, Merkleized abstract syntax trees?
Yeah, that's a mouthful, I know.
It is. What's the simple version?
The simple version is that Taproot is like a magic trick for data. It lets you hide really complex smart contract logic, making it look like a simple standard transaction. It compresses everything down and slashes the cost. So you combine Taproot's efficiency with the discounted storage space from SegWit, and boom, you've got the toolkit you need to put rich content on Bitcoin without it costing a fortune.
So really, those two upgrades together turned a cash system into something more like a super secure, decentralized hard drive.
That's a perfect way to put it. The engineers built the foundation.
Okay, fantastic. So now we move from engineering to philosophy, I guess.
Right.
Ordinal theory. This is the idea that turned Bitcoin's currency into unique canvases.
Right. Ordinal theory is, at its core, a numbering scheme. It just assigns a unique serial number, an ordinal, to every single Satoshi, which is 100 millionth of a Bitcoin.
Based on when it was mined.
Exactly. First in, first out. And just by doing that, you transform a Satoshi from this fungible, interchangeable coin into an individual, trackable item, an item that can carry data, an inscription.
And that numbering also created a kind of built-in rarity system, which is going to be important when we talk about Natcats.
For sure. The system looks at Bitcoin's own timeline. The first SAT of a new block is uncommon. The first SAT after a difficulty adjustment, which happens every 2016 blocks, is rare. After a halving, epic. So you get these tiers: common, uncommon, rare, epic, legendary, mythic, that aren't just made up. They're tied to the unchangeable physics of Bitcoin itself.
That sets the stage perfectly for digital matter theory, or DMT. If ordinals gave each Satoshi an ID, what does DMT do with it?
DMT is a philosophy about discovery, not creation.
Yeah.
It says the most valuable digital assets are the ones you find by mining the data that already exists on the Bitcoin blockchain, data that's been generated autonomously since 2009.
So things like what? The block hash, the block height?
Exactly. Block hash, size, height, the mining difficulty, all this data that the network creates on its own. The analogy is like discovering chemical elements in nature. You don't invent gold, right? You just discover it, name it, and figure out what to do with it.
I love that. So the artist or creator is just defining the rules for how that existing non-arbitrary data should be interpreted.
Precisely. The data is immutable because the network decided it, not a person. The inscription process itself just wraps the code in a taproot script and locks it onto the chain forever. It's completely, fully on-chain.
Which brings us right to Natcats. They're sort of the poster child for this, pioneering the UNAT standard, the unique non-arbitrary token. What makes them the perfect example of DMT?
Well, Natcats are these collectible cats, but they are produced completely autonomously using Bitcoin block data as the only input. The big difference between them and, say, most other NFTs is where the scarcity in traits come from.
Right, a lot of NFTs use smart contracts you can change, or they store the art off-chain on IPFS or something.
Exactly. Natcats are different. Their supply, their very existence, is tied directly to the fixed, unchangeable data stream of the Bitcoin blockchain itself.
Okay, let's get into the mechanics of that. I find this part fascinating. How does the system decide when a new Natcat is born? Tell us about the 3B rule.
Okay, so a Natcat can only be produced when the hexadecimal code for a block's bits field, which is just the technical value for the mining difficulty, contains the specific pattern 3B. That's it. That's the rule.
And that's not a random choice. It's tied to the economic physics of the network itself. How rare is that pattern?
It is exceptionally rare. I mean, think about it. We've had over, 900,000 blocks mined since Bitcoin started, and that 3B pattern has only shown up 4 times.
Wow, only 4 times in 15 years.
Yeah. And since a generation lasts for 2,016 blocks, that gives us the current total supply of 8,064 cats. The creator didn't pick that number. The blockchain's math did.
That's what's so compelling. It's not a programmer saying, let's make 10,000. It's Bitcoin saying, this rare event has happened 4 times. Here you go.
And that leads to this totally unpredictable future supply. The next time we see that 3B pattern, it could be next year, it could be in 50 years, or honestly, it might never happen again. The supply is completely out of anyone's control.
And the cat's traits, its appearance, is generated the same way from the block data. Can you give us some examples of how a block number determines a cat's genes?
Sure. It's all based on the properties of the block number itself. So, for example, if the block number ends in the digit 7, the cat gets a green face. If the block number is a multiple of 69, it has a spikes collar.
Okay, I follow the determinism there. The block number is the block number. But wait, someone still decided that the number 420 in the block height gives the cat a catnip sig trait, right? Isn't that part arbitrary? How do you square that with the theory?
That is a fantastic question, and it gets right to the heart of DMT. Yes, the founder chose the artistic association. They decided 420 equals catnip sig. But the input data, the actual appearance of the number 420 in a block number over Bitcoin's history, that was determined purely by the autonomous mining process.
Ah, I see. So the creator just built the lens, but Bitcoin itself provided the subject matter. The input is non-arbitrary.
That's the key. And because the future supply is unpredictable, the rarity of existing traits is also totally dynamic. If future blocks happen to have 420 in them a lot, that catnip sig trait becomes less rare over time. The rarity is alive, it evolves with the blockchain.
So let's zoom out. This is all technically and philosophically very cool. But why does any of this matter for Bitcoin as a whole, beyond just digital cats?
It matters immensely for Bitcoin's long-term security. All this activity, people minting ordinals, trading DMT assets like Natcats, it all generates transaction fees.
And fees are going to become more and more important as the block subsidy from mining goes down with each halving.
Exactly. Eventually, transaction fees have to be the primary incentive for miners to keep securing the network. So this new use case, embedding data, guarantees a constant stream of fee revenue. It directly contributes to Bitcoin's security budget for the next century. It's crucial.
And what about decentralization? How does a project like Natcats stay autonomous? The founders can't stick around forever to manage the minting of Gen 5, right?
This is probably the most revolutionary part. They built what's called a P2P perpetual distribution system. So for all future generations, when a new 3B block is finally mined, the system takes that new block's hash.
The unique fingerprint of the block.
Right. And it uses that hash as a kind of deterministic lottery ticket. It automatically and verifiably selects one existing Natcat holder to be the parent of the new generation.
So it's totally hands-off. The blockchain itself just picks a random holder and gives them the minting rights.
That's it. It's all deployed on-chain, requires zero central coordination, no reliance on the original creators. It's a truly autonomous governance model that just leverages the built-in randomness and determinism of the network.
And this whole movement has obviously had ripple effects. We're seeing copycat protocols on other chains like Dogecoin or Ethereum.
For sure. And all this new demand has forced the Bitcoin ecosystem itself to innovate. We're seeing a rapid build-out of Layer 2 solutions, ZK rollups, stacks, Lightning Network assets, all being developed to handle the transaction volume that these new native assets are creating. It's leveling up the whole space.
You know, this whole deep dive really shows how incredible utility can be discovered inside of what seems like an absolute constraint. Digital matter theory completely reframes how we should look at digital assets. It's moving away from flexible smart contracts and toward raw, inherent on-chain data.
And what's really mind-bending is the time scale we're talking about. The story of these assets is being written block by block, and it's a story that could easily span a century or more. The creator, the first owners, us, we're all just witnesses to this autonomous evolution that will keep going long after we're gone. It's a perpetual digital story, written entirely by Bitcoin.
A story that's really only just begun. You've got plenty to think about now.